So exponents. So let's just review some things, okay? So if I have 3 to the 4th, what does that actually mean? 3 times 3 times 3 times 3, right? We're doing it 4 times, okay? So remember, this is called your base. This is your exponent. Okay. We have our base and we have our exponent. Okay. So I know that 3 to the 4th means I'm multiplying 3 times itself 4 times. So what if I have 3 to the 4th times 3 to the 2nd? Okay. Well, 3 to the 4th, that's 3 times 3 times 3 times 3, right? There's your 3 to the 4th. Times 3 to the 2nd, which is 3 times 3. So how many times have I multiplied the 3? 6 times. So we can write 3 to the 6. Does anyone see a shortcut to that? Because I don't want to have to write the numbers out like that. Just add them, yeah. So our shortcut is that we just add the exponents. Okay. If I have the same base and I'm multiplying, all I have to do is add the exponents. Okay. Please make sure you're all copying these examples down. If I have the same base, so let's say that I had x to the 10 times x to the 7, right? I don't want to write all those x's out. So all I have to do is add the exponents, 10 plus 7, so I get x to the 17. Okay, is that familiar to all of you? We've done that before in Algebra 1. Okay. So of course we always try to make it a little more complicated because we don't want to keep you too bored, right? So let's say that I have 3 a to the 3rd b to the 4th times 4 a to the 6th b to the 2nd. Okay. Now I know that some of you can just look at this and do it in your head. That's fine. But for the rest of you, we're going to write it out just to make sure that we're on the same track here. So what I'm going to do, right, this is all multiplication. 3 times a to the 3rd times b to the 4th times 4 times a to the 6th times b to the 2nd. Remember, the order that we multiply does not matter, right? If I had 2 times 3 times 4, that's the same thing as 2 times 4 times 3, or 3 times 2 times 4, right? It's all the same. Doesn't matter what order we multiply. So I'm going to rearrange these and I'm going to group the like terms together. So I'm going to do 3 times 4 times a to the 3rd times a to the 6th times b to the 4th times b squared. That's going to help me to see what exponents I have to add together. Okay. All I did was rearrange it, putting my like terms together. So now we have 3 times 4, which is 12. How about a to the 3rd times a to the 6th? A to the 9, right? We have same base, so we add the exponents. And the b's, I have the same base, so I'm going to add the exponents. That becomes b to the 6th. And we're finished. Okay? 12, a to the 9, b to the 6 is my answer. Question on that one? Okay, let's do another one. Oops, sorry. Okay, let's do -2 x to the 9, y to the 3rd, z to the 6th times -4 x to the -3, y to the second. Okay. So we're going to group our like terms. So we're going to do negative, oops. Yeah, I'm going to use parentheses. Anytime I have negative numbers, it helps me to use the parentheses. Okay. Okay, so because I have negatives, I'm using parentheses. Otherwise, if you write it like this, -2 times -4, it looks like minus. It looks like -2 minus 4. And that gets confusing. So when I have negative numbers, I use the parentheses. Okay. And then we have x to the 9 times x to the -3rd. And then y to the 3rd times y squared. And then we have z to the 6, and there is no other z, so we just leave z to the 6 alone. Okay. Okay. What's -2 times -4? Positive 8. Positive 8. Okay. X to the 9th times x to the -3rd. X to the 6. Y to the 3rd times y squared. Y to the 5th. And then we have z to the 6th. We're done. Okay? Questions? Okay. Let's look at, yes, sir.
We got the 6 from first.
9 plus -3 gives me 6. Right? We add the exponents. Okay? Everybody should have this copied down, have these examples in your notebook, because come May, you will not remember. Okay. Let's look at division. So let's say that we had a to the 4th over a to the 3rd. Okay. Well, that means I have 4 a's on the top and I have 3 a's on the bottom. Okay. Everybody copying this down, Tristan? I have 4 a's on the top, 3 on the bottom. So what happens? Yeah, they cancel. All these a's cancel, leaving me with just 1 a on top. So that's just a. Okay. What's actually, what not actually happened, what we can do as a shortcut, when we were multiplying, what did we do with the exponents? Add them. So what do you think we're going to do when we divide? Subtract. So this is a to the 4 minus 3, which means that equals a to the 1st. And that's what I got doing it that way.
If you just left it as A, would it be right?
Yes. Yep. Okay.
So you only subtract them when you're dividing.
That's correct. We subtract exponents when we're dividing.
And you multiply them.
Mm-hmm. So let's look at another example. Let's say that we have 8 x to the 5th, y to the 3rd, z to the 4th over 2 x to the 2nd, y to the 1st, z to the 3rd. Okay. Okay. We are going to separate, and then we'll work with it, and then we'll bring them back together again. Okay? So over the holidays, when my son came, he has a new dog. He has a 9-month-old dog. It's a mix of golden retriever and Great Pyrenees. It's huge. I have a golden retriever that's 8 years old, and this dog towers over my dog, and their dog is 9 months old. It's huge. It's completely out of control. He has no discipline over it whatsoever. This dog is running his household.
He stinks.
Okay.
What breed is it?
Golden Retriever and Great Pyrenees.
I was gonna Great Pyrenees and Saint Bernard.
I bet that's even worse.
Yeah, it's bigger.
So bigger, and this dog is so out of control. But anyway, when he arrived, my dog, like, we hardly even ever have a collar on her. She just, like, she doesn't go anywhere. She's so obedient. Golden retrievers are wonderful. Half the time I don't even have to speak. Half the time I'm just like, and she does what I want her to do. It's just like, I go out the door and I just go like this, and she doesn't move. I don't have to worry about my dog. She's fine. So they got there, and of course my dog gets all excited because she saw my son, and she's like runs over to say hello. Well, out comes this big, ginormous, out of control dog, and they had her on a leash, but it didn't matter because she was ginormous. So my son was saying hello to me, so his fiance is holding the dog, but the dog is like pulling her every which way. So the two dogs, met and got into it, and my dog was very angry, and his dog was like, "Oh, let's play," So clearly didn't. So right away we're like, "Oh, whoa, separate them." So he yanked his dog off. I took my dog on, made her sit down, settled her down. She was all upset, and then we put a leash on my dog. Right? We separated them. We worked with them. He got his dog settled down. And then what did we do? Then we came back together, right? We separated them. We worked with them, came back together. Then they were fine because my dog knew it was okay. His dog was still going, woo, but my dog was like, okay, this is fine. I can deal with this. This dog's okay, right? So everything worked. That's what we're going to do. We're going to separate it. So we're going to separate it. 8/2 times. I'm going to separate the x's, x to the 5th over x squared, times y to the 3rd over y, times z to the 4th over z to the 3rd. I'm separating them all, and now I'm going to work with them. Okay? Separate them first and then work with it. 8/2, what does that equal? 4. 4 times x to the 5th over x to the 2nd. What's that equal? X to the 3rd times, what's y to the 3rd over y? Y to the 2nd times y to the 4th over y to the 3rd. I'm sorry, z to the 4th over z to the 3rd. Z. So I separated them. I work with them. Now we'll just combine them. 4x to the 3rd, y to the 2nd, z. Yes, sir. Ma'am, sorry.
Do we have to show work on our homework?
This is pretty straightforward, so a lot of you can just do it right in your head, yes.
So therefore we don't have to show work?
No.
Not on the ones that you don't need to. Okay, let's look at something different. Let's do 3a to the 2nd, b to the 8th, Najee, you turned the wrong way, c to the 5th over 12, a to the 5th, b to the 6th, c to the 3rd. Okay, so we're going to separate them. So I'm going to say for now, I do want you to write it out like this. So I do want to see your work for now. Later on, once I know that we all get it, then I'll let you go directly to the answer. Okay, so for now, you're going to write it out like this. A to the 2nd, a to the 5th, We've got b to the 8, b to the 6, c to the 5th, c to the 3rd. Okay, so we separate it. Now we're going to work with them. What's 3 over 12? 1/4, right? 1 over 4. Okay. Now we subtract our exponents. So this is going to be, I'm going to write it over here. This is a to the negative, what is it? 3. 2 minus 5 is negative 3. Okay, now I don't want negative exponent. So when you have a negative exponent, this is over 1, right? When you have a negative exponent, you make it positive by moving it. It's on top, so I'm going to move it to the bottom. So this becomes 1 over a to the positive 3. Okay. If it was on the bottom, let's say it was down here. Let's say it was down here. How do I make it positive? I move it to the top. So you move it and it becomes positive. That's how we make the exponent positive. We just move it. If it's on the top and negative, you move it down. If it's on the bottom and negative, you move it up. Yes, D'Angelo.
I thought you would divide 3/8 to second by 12, then like wouldn't it be? I thought it would be like 4/8. Like why can't you have a negative exponent?
Say it again.
So like, alright. So I thought you know how 3 is the top, right? 12 is the bottom.
Yeah.
Wouldn't you divide 12 by 3?
Right, we already did that.
Right. So then why can't you have a negative exponent and leave it as 4?
Because it's not the 4, it's the A. That's so we separated them, right?
Yeah, but like then you like
We're gonna do it. Just be patient. We're gonna do that. All right, just be patient. Okay. Okay. So this becomes, right? It's a to the negative 3, so that means it's 1 over a to the 3rd. Now another way of thinking of this, right? Instead of worrying about the negative exponent and then moving it down, right? If you look at this, how many A's do I have on the top? 2. And how many do I have on the bottom? 5. So when I cancel, where are the A's going to be left? On the bottom, because there's 5 down there. Only 2 of them cancel, so it leaves me with 3 on the bottom. So that's how I do it. I look at them like, okay, I've got 2 up here. That cancels 2 of these, leaving me with 3 down there. Okay? Okay, let's look at the B's. What do we have with B? B to the 2nd. And then the C's, we have C to the 2nd. Okay? Now we separated them. We worked with each one. Now we're going to bring them back together. So all we do, just draw a line straight across, because when we multiply fractions, we multiply straight across the top and then straight across the bottom. So this equals B to the 2nd, C to the 2nd, over 4A to the 3rd. That's our final answer. You should all have this example written in your notes. Everyone should have this example written in their notes, right, Andriana? Hey, Lonnie? So, have I ever closed my eyes in class with you guys and gone to sleep? Have I ever put my head down on the desk?
no.
So why do you think that's okay to do to me? Right? Why do you think that's respectful to do that? If you need to stand up, that's okay. Stand up and stretch, that's okay. Okay. Okay, let's do another one. Yes, sir.
If you left it as like the answer above, it would be right.
No. You had to simplify it.
How did you simplify it?
I just drew a line straight across and squished them together, brought them back together. 1, b squared, c squared, right? They're all multiplied, right? They're all multiplied. Just squish them back together.
Where's the one?
1 times 1 is 1, and you don't have to write the 1. You could put a 1 there, but you don't have to.
I'm so
Okay.
confused. Why did you put it in that form? Why can't you just like, I did it in my head like straight across. Why did you put it like that?
Did you get this answer?
Well, yeah, but I left the negative 3 alone. I'm still confused on why you can't have a negative exponent.
You can't have a negative exponent. You just can't. It's not algebraically correct. It's not acceptable. No negative exponent.
So if I were to do
So do it my way, because this is how you're going to get the right answer. Just do it this way. Do it this way. I know. That's the problem. We sometimes we learn bad methods. Okay, let's try another one. Let's try 4 x to the 5th y to the 2nd over 6 x to the 7th y to the 5th. Okay? We're going to separate them. So we've got 4 over 6 times x to the 5th over x to the 7th times y squared over y to the 5th. We separate them first, and then we can work with it. Okay, now we don't have to worry about negative exponents if you just pay attention to what's happening. Okay, first of all, we got 4 over 6. What does that equal? 2 over 3. Okay, so 2 over 3 times. Now I've got x to the 5th over x to the 7th. That means I have 5 x's on the top and 7 on the bottom. These 5 x's will cancel 5 of these x's, leaving me with what? 2 on the bottom. Okay? Times, what happens with the y's? 2 of the y's cancel 2 from the bottom, leaving me with 3 on the bottom. Does everybody understand how we got that? Okay. Okay, now we're multiplying fractions. When you multiply fractions, you just go straight across. 2 times 1 is 2. 3 times x squared times y to the 3rd. And there's our answer. Okay. For now, I want to see you do this work. I want to see you written out like this.
Can we only do this way if it's like fraction?
If it's division, yes. Yes. Okay. Okay, let's do another one. So let's do let's do negative 2 x to the 5th, y to the negative 3rd, z to the 2nd, over 10 x to the 2nd, y to the 4th, z to the 5th. Okay. Please make sure you're writing this in your notes so you have some place to check when it comes time for your exam. What do you need, Ethan? Okay, so what are we going to do? Separate them. Negative 2 over 10 times x to the 5th over x squared times y to the negative 3rd over y to the 4th times z squared over z to the 5th. Okay. So now we have some work to do. This is going to give me negative 1 over 5. Okay, x to the 5th over x squared. What's that give us? X to the 5th over x squared. What does that give us? X to the 3rd. X to the 3rd, right? So there's more x's on top, so I know I'm going to have my x's left will be on top. So we could, if you want to, you can put this over 1 if that helps you to understand. Okay. Times. Okay, now we have to do something with this because I have that negative exponent. What did I say we do when we have a negative exponent? Move it, right? If it's a negative exponent, so y to the negative 3 is actually equal to what? 1 over y to the positive 3rd. When it's a negative exponent, we're going to move it. Write that in your notes. Move it. Right? When it's a negative exponent, we move it. So I'm going to move it off the top. So down the bottom, I have y to the 4th, but now I'm moving the y to the 3rd down there. Okay, so we move it because it's a negative exponent.
So you just take the top one and just put it at the bottom, no matter what?
If it's a negative exponent on top, yes.
So the 4 and a 3.
Wherever it is, you move it to the other place.
So you don't have to worry about the bottom number?
We will come back to that. We'll come back to it. Let's work with the z. 1 over z to the 3rd. Everybody good with that? Okay. So what do we have now? We have negative 1 over 5 times x to the 3rd over 1. Now, I moved the y down. So now I have y to the 4th times y to the 3rd on the bottom. So what do I have on the bottom? Y to the 7th. When we're multiplying, we add the exponents. Okay, times 1 over z to the 3rd. Okay, when we're multiplying the same base, we add the exponents. Okay, so what did I do? First off, this is a negative exponent, so I moved it, in this case, to the bottom. Then I had to add those exponents, so I end up with 7 on the bottom. I had 4, I moved 3 down, now I have 7 down there. Okay, now let's go ahead and take our line, go straight across. So we have negative x to the 3rd over 5 y to the 7th z to the 3rd. Okay. Okay, we're going to do another one. Okay, let's do a to the negative 2nd, b to the 5th, c to the 3rd over a to the 6th, b to the negative 8, c. Okay. Okay. So I'm going to separate them. Separate them, and then we'll work with each one separately, and then we'll bring them back together again. Okay. Okay, what do I do with that a to the negative 2nd? Move it to the bottom. Yes, so this becomes 1 over a to the 6th a to the positive second. When you move it, you change it to positive. Times, what do you think we're going to do with that b to the negative 8? Move it back to the top. Yeah, so we have b to the 5th, b to the 8 over 1. And then the c, those are normal, so what's happening here? C to the 2nd. Okay. That gives me 1 over a to the 8th, 6 plus 2 is 8, times b to the 13 times c squared. We draw our line straight across. So we have b to the 13, c to the 2nd, over a to the 8th. And we're finished. Okay. Okay. So we are going to have a quiz. Quiz Friday. Okay. Quiz Friday will be on exponents. Okay. And I have a worksheet for you to work on now and for homework. And don't forget, we will have a mini quiz tomorrow based on your homework worksheet. Okay.
Wait. So a quiz tomorrow and a quiz on Friday?
The quiz tomorrow is the homework mini quiz, which means it'll be one question from your homework.
Oh, we have you tomorrow?
Right.
Okay.
Sorry?
We have you tomorrow?
We don't have.
Yeah.
Thursday. Thank you. Thursday.
Oh.
Okay. So when's this homework due?
8 a.m.
8 a.m. on Thursday morning. Okay. So if you forget, I'm not going to count it, right? If you hand it in when we have class, I'm not counting it. 8 a.m. it's due. Okay. Okay. Any questions for me? Because people were not doing their own homework. And they were taking time away from my class, uploading it when we get to class. Yes, sir. Okay.